Hello everybody, so today we're going to be revising ellipse and hyperbola. I've already done circle and parabola, so if you want to check those videos out, go check out my channel. Now let's get started. The notes you're seeing here are from JEE Brief by Vora Classes and some of my own notes from my own coaching. So let's get started. So first of all, what is an ellipse? Ellipse defines the locus of points. So basically in the last video we talked about PS by PM. So we define a fixed point, one fixed line, and based upon the distance from the fixed line to the fixed point, the ratio, we define 4 conics. One of those conics was ellipse. We defined the ratio of PS by PM to be E, and if E is less than 1, then it's an ellipse. Ellipse can be defined as the locus of all points which are closer to focus than they are to directrix, or they can also be defined as locus of a point such that the sum of its distances from two fixed points remain constant. So right away we're getting to the first point that I want to talk about. Let's say I assume this point P. This is one focus which is S. This is the other focus which is S dash. Now let's say I calculate PS dash. I calculate P. PS plus PS dash is always going to be constant, and it will either be equal to 2A if you are in a horizontal ellipse or 2B if you are in a vertical ellipse, but we'll talk about that more in detail later. So yeah, like I said, this point right here is S dash, which is one of the focus. This is another focus. The vertex is 0, 0. This line that I'm highlighting right now is the major axis. This line I'm highlighting right now is the minor axis. So basically this is longer, so we call it the major axis. This is smaller, so we call it the minor axis. Vertex of an ellipse is always going to be the end points at the major axis, which here is minus A, 0. I'm assuming that the length from the vertex, this is the center, from the center to the end of the ellipse is A. This distance is B. So this point is A, 0. This point is minus A, 0. Now this point is B, 0. This point is minus B, 0. This focus coordinates are AE, 0 and minus AE, 0. Now if you're ever getting confused about, so we're going to learn the directrix equation. Let me just show that as well. The equation of the directrix, now we're talking about a horizontal ellipse here. So the equation of a directrix is going to be x equals to plus or minus A by E. We're going to have two directrices, two foci as well. So this is x equals to minus A by E. This is x equals to A by E. If you ever get confused about whether the focus is AE or A by E, just think about, the eccentricity is less than 1. For an ellipse, focus is closer. So if you multiply A with something less than 1, it's going to be, a value, okay? Now here for a directrix, you're dividing it with something that's less than 1. So its overall value is going to increase. And like I said, the focus has to be closer than the directrix for any point that's on the ellipse. Again, the diagram here is not drawn to scale, so just look at what I'm saying. Now in this case, because it's a horizontal ellipse, PS plus PS dash will be equal to 2A. Right, so I'm just going to clean it up a bit and then we can talk about latest rectum. So like I said, this line or this line is the latest rectum. Obviously, like I said, this is the coordinates of the focus. So endpoints of the lattice rectum will be AE, AE. So the x coordinate is going to be AE for both. Here it's going to be minus AE, minus AE. Now if you substitute it in the curve, which is for an ellipse, for a standard ellipse, it's going to be x square plus a square plus y square by b square equals to 1. You'll get the other coordinate, which is going to be plus b square by a minus b square by a. Same here, minus AE comma plus B square by A minus AE comma minus B square by A. From this you can understand that the length of the lattice rectum is 2B square upon A for a horizontal ellipse. So here the way I remember it is 2 into whichever length is the smallest, like from between A or B, whichever is the smallest, square that upon which is the bigger number. 2A is called the length of the major axis, 2B is called the length of the minor axis. The same you can say that A is the length of the semi-major axis, B is the length of the semi-minor axis. If we talk about the equation of the lattice rectum, then it's going to be x equals to plus or minus AE. Equation of the major axis here is y equals to 0, minor axis is x equals to 0. So how do we write the equation of an ellipse? If they give you the coordinate of one focus, the eccentricity and the distance from one point to the directrix. Let's say the focus is 3, 4, eccentricity is 1 by 2 and the equation of the directrix is x plus y plus 1. What you're going to do is understand that PS upon PM is E. So you're just going to take one random point and x minus 3 whole square plus y minus 4 whole square, which is the distance from any random point to the focus, upon the perpendicular distance from that point to the directrix. So that's basically going to be x plus y plus 1 upon root 2. You could, and then you have equal to 1 by 2. Just square it on both sides and you'll get the locus of the ellipse. Let's move on to formula for eccentricity. So the way I remember formula for eccentricity of an ellipse is 1 minus whatever is smaller squared upon whatever is larger. So upon between B and A is where I'm making this comparison. It can help you not get confused, and I think in ellipse it's usually harder to get confused because if you do the opposite, it's gonna turn out to be a negative number and that's just not defined. So next let's talk about a director circle. Like we said, a director circle is basically a circle from where perpendicular tangents can be drawn onto the ellipse. For an ellipse, the equation is x square plus y square equals to a square plus b square, and this director circle is concentric with the ellipse. So basically, if I were to give you an ellipse tomorrow and say the ellipse equation is x minus 2 whole square plus 16 by 16 plus y minus 1 whole square by 9 equals to 1, the director circle's equation is going to be x minus 2 whole square plus y minus 1 whole square is equals to a square plus b square. So 16 plus 9 is 25. This is going to be the director circle's equation. Now let's talk about auxiliary circle. Auxiliary circle, which is defined as the locus of feet of perpendicular drawn from any foci to any tangent that's on the ellipse. The auxiliary circle's equation is going to be x square plus y square equals to a square. Now again, all of this that I'm talking about is for a horizontal ellipse, right? So here the director circle's equation doesn't change either way, but for an auxiliary circle, here the whether you're gonna put A or B depends on whether it's a horizontal ellipse or the vertical ellipse. Whichever is greater, that's what you're gonna put, because if it's a horizontal ellipse, we're gonna put A, which is the greater number. If it's a vertical ellipse, you're gonna put B, which is also again the greater number. This auxiliary circle is also concentric with the original ellipse. So again, same example applies here. For this, if you were to write the auxiliary circle, you would write x minus 2 whole square plus y minus 1 whole square is equals to 16. Now let's just quickly look through this table. So I just taught you all about horizontal ellipse. Let's look at vertical ellipse. For a vertical ellipse, the eccentricity formula you can remember it like this, or e square is equals to 1 minus a square upon b square. The vertices are going to be 0, plus or minus b. The foci 0, plus or minus be. The directrices 0, plus or minus b by e. End point of latus rectum will be a square by b, plus or minus b. So I'd recommend you learn the length of latus rectum, and using that you can just kind of find the coordinates as well. So equation of major axis x equals to 0, equation of minor axis y equals to 0, and equation of latus rectum will be y equals to plus or minus be, whereas for the horizontal ellipse it was x equals to plus or minus ae. Right, so you can go through this table. You also have all these values, all these like sort of coordinates for an ellipse whose center isn't origin as well. So you can definitely look through that as well. Next, let's talk about tangents. So although tangents is deleted in ellipse, parabola and hyperbola, I just really think it's better to do a brief portion. So the condition for tangency in an ellipse is when we are assuming a line y equals to mx plus c, it is c square is equals to a square m square plus b square. So the line is going to be y equals to mx plus or minus root a square m square plus b square. Before we move further, I want to talk about parametric coordinates for an ellipse. For an ellipse, you are actually going to consider parametric coordinates a cos theta, b sin theta. Now, using this, we can write the tangent equation of an ellipse in terms of theta, which is s1 equals to 0. So s1 for an ellipse would be x1 by a square plus y1 by b square is equals to 1. Here substitute the points, you get x cos theta by a plus y sin theta by b is equals to 1. You can use the same to compare with another equation lx plus my plus n equals to 0 to derive another form of the condition, basically a condition for tangency, but this in my opinion should be fine. Now to write the normal equation, you can use you've basically got slope here. Using this and the point being a cos theta b sin theta, you can find the normal equation, or if you'd prefer to remember it, the normal equation in terms of theta is ax by cos theta minus by upon sin theta is equals to a square e square, or basically this can be written as a square minus b square. For a line lx plus my plus n equals to 0 to be the tangent to an equation, tangent to the ellipse, the point of contact is minus a square l upon n minus b square m upon n. Now if two tangents are drawn from an external point onto the ellipse, the angle between them is going to be tan inverse 2ab root s11 upon x1 square plus y1 square minus a square minus b square. x1 and y1 being the external point coordinates from which the tangent was drawn. Another point that I wanted to discuss was, let's assume S is one of the foci, S dash is the other foci, and P is a random point that's on the parabola or ellipse. Then 1 by SP plus 1 by S dash P is going to be equal to 2 by SL, where SL is the length of semi-latus rectum.